This video is going to review graphing quadratic functions. First of all, standard form of a quadratic function is when we have f of x equals ax squared plus bx plus c. And if a in that equation is positive, then the graph opens up like this. If a in that equation is negative, the graph opens down like this. The axis of symmetry formula when we're given an equation in standard form is x equals negative b over 2a. And to find the vertex, we substitute the axis of symmetry into the original equation. If the graph opens up, then the graph has a minimum at the vertex. If the graph opens down, it has a maximum at the vertex. The domain for quadratic equations is always all real numbers, and the range is y is either less than or equal to or greater than or equal to the y value of the vertex. If the arrows point up, then we will use greater than or equal to. If our arrows point down, we will use less than or equal to. So to graph an example, let's first talk about the characteristics. This graph will open up because A is 2 in this case and is positive. The graph will have a minimum because it opens upward. The axis of symmetry, we're going to use our formula, x equals negative b over 2a. So we'll have negative 8 over 2 times 2, which is going to give us positive 8 over positive 4, which is 2. So our axis of symmetry is x equals 2. When we find the axis of symmetry, we put that here in the middle space of our x column. To find our vertex, we can plug 2 into our equation. So f of 2, that's going to be 2 times 2 squared minus 8 times 2 plus 6. And you'll find that this is equal to negative 2. So our vertex is 2, comma, negative 2. This 2 from here, and this negative 2 from here. The domain, as always, will be all real numbers. And our range is going to be y is greater than or equal to, because our graph opens up, the y value of the vertex, which is negative 2. Now, I forgot to plug in the rest of the vertex, so let's go ahead and put that there. And then I've told you just to use your calculator to find the points on the rest of the points for the graph. When you type this equation into your calculator, your table should look like this. And then you will graph the points that you can. So the 16 will not go on here, but all the rest of our points will. So over 0 up 6. 1, 0, 2, negative 2, 3, 0, and 4, 6. And then put our parabola in. All right. So we have graphed an equation in standard form. Now let's take a look at vertex form. Vertex form of a quadratic equation is f of x equals a x minus h squared plus k, where x equals h is the axis of symmetry and hk is the vertex. A determines the width and the direction of the parabola, and vertex form shows the transformations of a function in respect to the parent function. The A tells us if there's a vertical stretch or a vertical compression, as well as if there's a reflection. And then H tells us the movements left and right, and K tells us the movements up and down. So looking at vertex form, all the things that we can tell about this, the fact that A is negative tells us that this will reflect across the x-axis. Then the fact that it's a 2 tells us there will be a vertical stretch by 2. Then this plus 4 tells us that the graph will move left 4. And finally, the plus 2 tells us that it will move up 2. So those are all the transformations that will happen for this equation. All right, A is negative, so this graph will open down, meaning the graph has a maximum. The axis of symmetry is x equals h, and if you recall, our formula is x minus h squared plus k. So this is going to equal a negative 4, even though we have this plus sign here. The vertex is going to be negative 4, comma 2. The domain is always all real numbers, and our range is y, and it is less than or equal because our arrows point down, our graph opens down, and then it is less than or equal to the y value of the vertex. All right, so let's put our vertex in the middle of our table. Then you would go to your calculator, type the function into y equals, and go to your table. And your table should look like this. And then you would plot your points that you're able to. So negative 6, negative 6. Negative 5, 0. Negative 4, 2. And back down. And our parabola looks something like this. All right, so now we have graphed an example in vertex form. And finally, the last thing that we've talked about so far is converting from standard form to vertex form. Standard form is this ax squared plus bx plus c. Vertex form is a, x minus h squared plus k. So we need to use a, b, and c to find a, h, and k. So to find a, we use the same a as from standard form. To find h, we use the axis of symmetry formula, negative b over 2a. To find k, we substitute h into the original formula. So in our example, a is the same a from standard form. This is standard form, so that's a, that's b, that's c. A is 2. H is the axis of symmetry, so that's negative b over 2a. So we'll have negative 8 over 2 times 2. We've already done this in a different example, and we're going to get that it is equal to 2. And then for k, we substitute 2 back into the function. So f of 2, we will plug 2 in for each of these x's, and that would give us negative 2. So to write this equation in vertex form, we'll have f of x equals a, which is 2, x minus h, which is also 2, squared, plus k, which is negative 2. So it's just going to be minus 2. And that is our equation now in vertex form. That's the same as this equation, just a different format. That's all for today's video. Thank you.